Hello, my name is Maggie Hubbard, and today I would like to talk to you about the effect of number talks on conceptual understanding of mathematics. I grew up in Dakota City, Nebraska, and graduated from South Sioux City in 2010. I then went on to college at Wayne State College and graduated with my education degree in 2014. After graduating, I got hired at South Sioux City Community Schools and as an EL teacher, which was a position I was at for 2 years. I then wanted to have that classroom experience, so I moved to third grade, where I've been for the past 4 years and love it. Through my master's program, I came up with this question: how do number talks help to build conceptual understanding of mathematical concepts? The reason why I came up with this question was for the last 3 years, I had noticed my students had had a difficult time with number sense. When it came to six-digit addition and subtraction problems, multiplication and division, students that did not have an understanding of what a number meant really struggled with becoming proficient with these types of problems. Throughout my research, I focused on 6 themes. The first theme I focused on was the purpose of number talks. Number talks are a brief activity whose purpose is to support students' mathematical sense-making and flexible thinking. Students are actively engaged and are able to develop number sense, understand there is more than one way to solve a problem, and learn to trust their own reasoning. Number talks focus is to support students in explaining their ideas and their reasoning using specific strategies rather than focusing on the correct answer. With number talks, students are able to make sense of their own mathematical ideas. But this only happens when students are given the opportunity to make sense of the mathematics for themselves. The next theme I looked at was number sense and mental math. According to an author named Sherry Parrish, students cannot be taught to have number sense. They need to have opportunities given to them in order for number sense to be developed. Number sense is tied into every area of mathematics. It facilitates problem solving, reasoning, and the discussion of mathematical ideas. When teaching with number talks, students are building their understanding and taking action in constructing their number sense, knowing that there are multiple ways to approach to solve a problem. Parrish also says that mental computation is a key component of number talks because it encourages students to build on number relationships to solve instead of relying on memorized procedures. When students are able to solve problems in their heads, they can use what they know about place value, relationships among numbers, patterns, and visual images to solve problems. And as teachers, it should be our job to direct what is going on in their heads. The next theme that I looked at was math discourse. According to the National Council of Teachers of Mathematics, discourse is a way to represent, think, talk, agree, and disagree in ways that students are engaged and lead to a learning environment. With number talks and math discourse, they are places where math talk can happen. They're interactive discussions that are key for students to make sense of what they're thinking because students are able to relate their own growth and understanding within the math talk learning community. Throughout math discourse, it should be the goal that all students are engaged and involved to share ideas and questions and to participate for all students. The next theme that I looked at was fluency. Math facts are just a small part of the mathematics that are best learned through using numbers in different ways and situations. This was something that I learned after reading a text by Jo Boaler. She also shared that according to research, the best mathematics classrooms are those where students learn number facts and number sense through engaging activities that focus on understanding rather than just rote memorization. When students are able To work on meaningful number activities, they apply those math facts to heart while understanding numbers in math. Fluency does not just mean speed. To be fluent means that students are comfortable with numbers. The fifth theme that I looked at was visual mathematics. Visual mathematics include anchor charts, which are key for students to access strategies they have learned and make connections between strategies. When using anchor charts during number talks or math discourse, they help focus on making connections between the different strategies that can be represented as students share their math thinking. When students are using anchor charts, they should be able to see how mathematical ideas and to be able to draw what they see. Working on mathematics pulls from different areas of the brain, which helps students become strong with visual numbers, symbols, and words. In a few slides, I'll show you what some of my anchor charts look like for my students. The last thing that I looked at was mathematical mindset. A mathematical mindset, according to Joe Bowler, is an active approach to mathematical knowledge where students know it is their job to understand and make sense of problems. When we as teachers help students develop mathematical mindsets, that's one of the best things we can do for them. Students will believe that mathematics is thinking, sense-making, and connections, not just memorizing the methods. When engaging students in number talks, that aligns closely with supporting students develop a growth mindset in mathematics, which is important for students to have. As I completed the study, I had 11 students that participated that were either 8 or 9 years old. The study was done in my classroom during the first 10 minutes of the math block for approximately 6 to 8 weeks. Before completing the study, I had permission slips signed from parents, students, my SPED instructor, and my school principal. When I was completing the study, I used the text Number Talks, Helping Children Build Mental Math and Computation Strategies, grades K through 5, to assist me with coming up with problems to work through with students. As I was completing the study, students' progress was checked using the map number sense strand, teacher observation notes, and student strategy check-ins. When I looked at the map data, I looked at the fall map data as my starting point. I looked at the winter as the end starting point, and I saw some awesome growth. Teacher observation notes, I took notes weekly on what I noticed with students and which students I wanted to pull back and work on strategies more with. And then my students took strategy check-ins throughout the study to see how they were feeling with each of the strategies being taught. Here are some examples of what number talks look like in my classroom. I was the person that scribed. I would give the students a problem, and then they would have to have time to think and then share out with me their strategies. They couldn't just tell me the answer. They had to describe it with me so I could record it for everyone to see what was going on in their head as they solved that problem. We mainly did addition throughout the study, but we did end with some subtraction before the end of the study. When it came time to look at the data, teacher observation notes were looked at completely all the way through the study as my guiding of where instruction should go. In the bottom left-hand corner, you will see the student check-in form that students filled out 3 times throughout the study. Then you will also see the graphs. The blue column means that the students thought that they could do a strategy all of the time. The red meant that they think they could do it sometimes, and the yellow meant that that was a strategy they felt that they needed more help with. The first 4 strategies we talked about were counting on, doubles and near doubles, making it 10, making friendly numbers. As you can see, 2 of them, students either knew them or they like to do them sometimes. Doubles and near doubles and making friendly numbers were strategies that students were not comfortable with and ones that I would make sure I would practice with them more frequently. Moving on to the midterm and the final check-ins, we had added 3 more strategies. We added up breaking each number apart, compensation, and adding up chunks. When we looked at those in the middle of the year, or the middle of the study, the 3 new strategies were definitely ones that students felt that they needed more practice with, that they weren't strong. But looking at the data at the end of the study, those numbers increased where students were more comfortable, but they still wanted more practice. If I were to give my students this survey again, I feel like that growth would grow even more for students in their understanding of the different strategies. Another data piece that I looked at was students' MAP data. Students took the MAP test in the fall and the winter. On the first chart, you'll see I have the first chart is the fall MAP, looking at what they scored on their number strand. Then the middle column is how many points students either grew or did not grow. And then the last is the winter MAP, where they ended our study at in the number strand. As a class, my students grew 103 points in the number strand column, which was awesome. All but one student grew in the number strand from fall to winter. Student 4 had the most growth with the number strand, and they grew 25 points. And you could really tell throughout the study that number talks were helping the student a lot. The next chart was mainly just for me to see which descriptor, looking at the MAP descriptors, which students stayed the same. Did any of them go down? Did any of them go up? Most of the students stayed the same. There were 2 students that showed improvement and 1 student that had lost some. But overall, I was very happy with my students' progress with number talks and that number strand throughout the study. So from my study, I came up with these conclusions. The students in this study generally seem to grow in their conceptual understanding of mathematical concepts. They seem to grow more comfortable working with large numbers and using the different strategies throughout the study. MAP data was a large indicator that students grew with their conceptual understanding of mathematical concepts. Again, they grew 103 points as a class, which was a great amount. From the data collected through this study, it can be concluded that number talks are beneficial for students' conceptual understanding of mathematical concepts. So for my implications, after completing this research, I have concluded that I will continue on with number talks with upcoming classes in the future. The benefits of incorporating number talks into my classroom include a warm-up before the math lesson. It was a great way to transition students to be ready for our math time. Students were able to learn new strategies to solve equations in the most effective way. Students were able to learn from other classmates, and students were able to make connections between number talk strategies and other math concepts being covered. If you want to learn more about number talks, I would highly suggest checking out resources from these experts. Joe Bowler, who also has a U-Cubed website that's full of great math resources. Sherry Parrish, who is the author of the Number Talk book I used as my guide for number talks. Kathy Humphreys and Ruth Parker have written several number talk books together. And Jessica Shumway. She also has some for number talks, but also is a great resource for early educators on just getting kids talking about math and different strategies. Thank you for watching my presentation. I hope you learned something about number talks and want to learn more and start incorporating number talks into your own classroom. Thanks again.